Hi, everybody. Welcome to today's webinar. I'm really excited about today's webinar and the guests that we have for you today. It's actually really special. I've been a big fan of our speaker today. I was just talking to him behind the scenes. So really great guy. Excited to have him share his knowledge with you and everybody. But before we introduce him, let's do some housekeeping. So as you may have guessed and why you're here, our guest today is Dominic Bayer of Duende Software. If you're watching us live right now on YouTube or Twitch or Twitter, feel free to ask any questions. We're mainly monitoring the YouTube chat right now, but I can also see some chat from other channels. But feel free to ask any questions. Our guest is really open to those questions and would love to hear from you. So feel free to ask questions. The big question a lot of folks ask as we go through these webinars is this session being recorded and will it be available on YouTube for later viewing? Yes, of course. Feel free to ask that question, but don't ask that question because I'm answering it right now. And short of that, let's introduce our guest today. His name is Dominic Bayer, and he is co-founder of Duende Software. You may already know him from using his open source package, Identity Server. So let's introduce Dominic. Hi, Dominic.
Hi.
How are you doing?
Hi. Good to be here. Actually, yeah, we were just chatting that I know Khalid for many, many, many years, but we never met.
Yeah.
Actually, we haven't even chatted yet, like, in person, so to speak, right? It was all about Twitter and whatever. So yeah, good to see you.
Yeah, you're one of my .NET heroes, so it's very nice to actually talk to you. And I can imagine a lot of people are here today because they know you from Identity Server, the work you and your co-founder, Brock Allen, have done with Identity Server. So in a way, it's kind of nice to actually talk to someone who's influenced the .NET community and kind of what everybody has been doing in .NET for a long time. So thank you on behalf of me and the .NET community.
I have the gray hair to prove that it's been a long time, yeah.
The thing you don't know about Dominic is he's only 22. So
right.
security immediately ages you.
With the age of 3. And no, Brock and I have been doing this. I mean, we actually worked together at a training company called Developmentor way back then. And while I joined them a little bit later, but yeah, the Developmentor was actually the company that did like they taught Microsoft employees .NET.
Mm-hmm. Wow.
Like before it even was released. So yeah, so we go back a long time. While Brock was there a little bit earlier, teaching COM and all that fun stuff before I basically started with .NET. And then when .NET 2 was released, it was actually a really interesting security platform because they, all of the hard stuff, but that you had to be like a C++ developer or a C developer actually before that, like the Kerberos and X509 certificates and so on, they were all wrapped in .NET. And, for someone like me who isn't smart enough to do C development, I just, it was very accessible suddenly. And ASP.NET was a great web platform, and ASP.NET 2.0. I remember I wrote a book about that, which, was very hard work for nothing, I guess. Was just a really good web platform with lots of interesting built-in security features. So that's how that all came together, I guess. Yeah.
Yeah, and I'm really excited about kind of where ASP.NET and ASP.NET Core is going. And I guess that's the topic for today. You're really going to talk about security and how it applies to ASP.NET Core, kind of the permutations of security that have occurred maybe over the last decade. Spoiler alert, it's all about the browser, right? Like what the browser wants to do, and you kind of have to fall into that place. So without further ado, I know a lot of folks are kind of interested in the backend for front-end pattern and how it might apply to Blazor and SPAs in general. So I'll give you kind of the floor, and you can go through the slides. Dominic has asked me to kind of keep this conversational. So if you feel like I'm interrupting him too much, folks, just let me know in the chat. But I'm just going to try to ask questions as we go through, and be sure to ask your questions as well. So,
yeah. So Exactly. So what I said earlier is that this talk, I have done this talk before at conferences, and there are recordings of this talk. So if you prefer like a full 60-minute, me doing a monologue kind of thing, that exists. But I think given that format, I think it would really benefit from having a dialogue, right? So that I'm not planning to go over all the slides, and not but I would totally appreciate if we would kind of have this dialogue as opposed to me just going over slides and doing demos. I think that's easier or more interesting. So the way I typically introduce this talk is that I was always a server guy, and I never really cared about front ends at all. Yeah, like UIs, I don't care about them. I never had the urge to write one. I think they're way too complicated. I don't like state machines. So I never really was interested in UIs and UI technologies. I saw them coming and going. I didn't pay attention. But obviously, as a backend guy, at some point you have to realize that the only reason you exist is because the backends you're building are meant for front ends to consume, right? Yep. And that's what our customers are doing, right? Our customers are building, front ends for their backends, right? and some of them do native, right? But the huge majority of them do some sort of browser-based front end applications. And I've seen them come and go, and I think I'm old enough now to have been going full cycle on that and saw several iterations of this. So as I said, I won't go through all the slides, but it's very interesting to see that if you are long enough around, is that and I, to be honest, I really felt bad for these front end guys all the time, because the guidance has changed so often how to build, especially a secure front end. That's really all I care about. Is it secure or not? There are, of course, much more, many more concerns about all of this. But from a security point of view, right? I mean, the thing you did yesterday is wrong today, and the thing they tell you to do today is wrong tomorrow. Kind of happened a lot in this area. Just because it's a work in progress, right? I mean, attack defense, like you do something which works, but now a new attack gets discovered, right? And to mitigate this attack, you have to re-architect what you've done before. So that kind of is what happened here, right? Mm-hmm. So the way I like to see that is like a pendulum, right? So we started with doing everything with cookies in the browser, and then suddenly cookies became a bad thing, and the pendulum was swinging more like doing tokens only, and then issues with tokens were discovered. And what I'm getting at is with this backend for front-end architecture, is kind of like we're now in the middle, right? Where typically the truth is, and it's the best of both worlds, where some parts are done in the front end, especially the things that the front end can do very well, like UI and interactive things. And some parts are done in the back end that the back end can do very well, when it comes to security, because as we'll learn in the next hour or so, the browser is a dangerous place.
Yeah, and just to kind of add to your, like, from my experience too, it's like clients have changed so much. Like it used to just be HTML and maybe a little bit of JavaScript, and then we got to like full SPAs with JavaScript, and now we're moving into WebAssembly. So you have this like code. Yeah, that's
exactly what I mean here, right? So I did classic ASP before I did ASP.NET, right? And ASP.NET, I did web forms and I did MVC, and many of our customers, they started with this web forms or MVC application, right? Like classic server rendered application. You render the page down, you have a form, post back, it goes all back to the server. It was secured by cookies. Mm-hmm. And then somewhere along the lines, right, this Ajax style thing came in, where Microsoft shipped this thing called the Ajax control toolkit, right? And jQuery was part of the MVC distribution, if you like. And, you probably also remember these days when Microsoft guys went on stage and showed like, hey, look at that. No flickering in the browser anymore. No more postbacks. Yeah. Great.
Shout out to Update Panel.
Yes. Exactly. One of the best, innovations of all times, I guess. Yes, exactly. Ajax became the thing to make your UIs more responsive. Yeah. But, and because these applications started being, classical web applications, they were secured using, classical cookies, right? And the nice thing about Ajax was it just worked, right? You made an Ajax call, the cookie was just flowing along, no extra code to write. Your web API-ish endpoints in the backend had their, user session. It all was fine, right? And then, cross-site request forgery was discovered, which is basically, exploiting this implicit nature of cookies where the browser is just sending it along, and it all just worked, right? And just to make sure everybody understands the problem is that, so the way I like to think about browsers today, right, is they're like small operating systems, right? I mean, they have all these processes, and each tab is a separate application. And the troublesome thing that a browser has to deal with is that, in each tab you load up an application, but they are definitely not all trustworthy, right? So the fact that so many attacks exist with the word C, like cross at the beginning, right, explains kind of like the problem here, that most attacks is where one application is trying to attack another application, or in browser terms, one site is trying to attack another site. And if they run in the same browser in different tabs, there are shared resources. Yeah, like just like the file system in operating systems, there are shared resources in the browser, and one of them is cookies, right? So the way cross-site request forgery really works is, right, you open a tab, you go to app.com and you log in, you get your authentication cookie, and all is good, right? And now you can do your fancy Ajax, and it all works. Now, if you go in the same browser to a different tab, right, to like an evil application, that evil application can now start making network calls back to the backend of app.com. And because the browser says, hey, I have a cookie coming from app.com, let's just happily send this cookie along. And now suddenly the evil application is now impersonating the user logged into app.com, right? That's cross-site request forgery. I mean, that's exactly what it is. And one of the biggest first examples of that was Amazon, right? Like, if you remember the one-click buy button, where basically you could have a URL with some heuristic parameters, and if you went to this URL, you were buying a book, right? And if somebody made you go to that URL, maybe the image tag of the source attribute of an image tag was pointing to this URL. You browsed the website, you were logged onto Amazon, you bought a book. Yeah, that's exactly what it is. It exploits the fact that there's a shared session between browsers in multiple tabs.
Yeah, I remember one big attack when this first started coming out was like banks. People were doing like money transfers out of people's bank accounts because they knew that the bank had this cross-site request forgery attack possibility. So people's bank accounts were just getting completely wiped out because security measures weren't in place to mitigate it. So yeah, it's scary stuff.
So one of the most impressive attacks I've ever seen was where people were exploiting the fact that some of these home network routers are maintaining a session for the admin page, and then they were using basically GET requests to reconfigure your DNS server at home. Yeah.
Oh my.
And if an attacker can control your DNS server, it's game over, basically. Yeah.
Yeah.
That's I mean, pretty cool. Yeah.
It's cool, but it's also scary. Like,
sure.
I think you've said this before in the past. It's like attackers are very persistent. Like they're like no matter how secure you feel, they're going to persist and they're going to find a way. So it's like kind of goes to what you're saying is like, we may have best practices today, but as soon as a vulnerability is found, it kind of throws all those best practices out the window, right?
It's an evolution, right? We do something, people find a way to attack it, we harden that, and so on. Yeah. So yeah, I mean, a very simple, a very, very simple demo of that is basically just funnily enough, I'm teaching a lot, and there's always someone in the room that's like, this cannot be. I can't believe that this is really happening, because if that would be the case, the web would be broken, right? And I mean, yes, he's right. Yeah,
the web is broken, but it's a beautiful brokenness, I think.
Yeah. Just stay out of the dark corners, I guess. Yeah. But yeah, anyways, just to very, very quickly visualize this concept. Yeah. So basically, that is a classic MVC style application. I'm logging in, right? Now I'm logged in as Alice. An authentication cookie was set, right? We can see this here when we go to our cookies, right? There's an ASP.NET Core cookie, and now Alice can, do work as Alice, right? Because we have a cookie, right? And now, just to show that there's also an evil app, yeah. And I mean, who could resist, right? I mean, we can see kittens, right?
I love kittens.
So before you want to see kittens, let's actually have a look at what the page is doing, right? And you see that I don't even need JavaScript for this at all, right? Actually, I just make them click a button to do a cross-site post to this other endpoint in the other application, yeah? And of course, I could use JavaScript to auto-submit the form, right? The form could be invisible even in an iframe, whatever. So there are all kinds of things you can do. But ultimately, what will happen is application 1 will post to application 2, and because the browser's cookie logic is like, hey, I have this cookie, right? It will flow along, and not surprisingly, when I click this, I'm doing work as Alice. Yeah. So, and to be honest, this is not, I had to turn off a couple of security features in ASP.NET Core to make this even work. Yeah. But, fact is, this is, we're looking at like 10, 15 years ago. Yeah. Like, how did web development work at the time? Yeah. And of course, probably everybody should know, doing web development, that there is a mitigation technique, which is, of course, called anti-forgery tokens. Yeah. Where basically in your application you decorate your where is my action here, do work, with this thing called validate anti-forgery token. And the idea is that when the browser renders down this form, there's a hidden field in the form, and there's also a cookie. And now when you post back the page, they match that the value in the cookie is the same as in the form. And only if those values match, then this filter here will allow the request through. And the attacker doing the cross-site post would not know that secret value in the form, so it wouldn't work, right? That's kind of like since MVC 1.0, this was on every single template, and that's why people know about it. Yeah, typically. So if I run my app again now with this simple change, right, and would go to evil app, that's this guy. You see now it's not working anymore, right? So that's the attribute doing the work, and people knew about this for MVC style of work, but the Ajax thing now brought in technologies like Web API, right, so that you can call APIs from JavaScript. And they did not have that built in, right? So I did a lot of code reviews in my life where this was just not enforced, or people didn't even know about that this was a problem. So cross-site request forgery is definitely a real attack against many of these older JavaScript Ajax applications that did this Ajax calls but did not think about this attack vector, so to speak.
Yeah, I think it's also interesting when this was first released. It's like some people use this bug almost like a feature of their application. So it's like you're trying to mitigate an attack, but you've actually leaned into it, and now you have to figure out how do you provide the same functionality without leaving yourself open for attack. So it's kind of an interesting problem to face.
And kind of the evolution was that in MVC you first had to do this, right? And then they added another thing called auto validate and default token, which you can put on a controller, so that all actions are automatically validated. And then this could also be like a global filter that you add in MVC. And now when you switch to Razor Pages, it's always turned on, and you actually have to turn it off if you want to not validate and default token. So that's kind of like an interesting evolution that, you know, the whole secure by default approach. Yeah. Okay. So that's that, right? And as I said, this was exploited a lot, yeah. And as I did many code reviews where I found this problem, yeah. So, which leads us to the second part of that story, really, which is what I call the token era, right? So the IETF looked at these problems and said, like, you know, with OAuth, we could write these types of applications without cookies at all. We would use access tokens instead, and the benefit of the access token would be that since the browser is not sending them automatically and we have to explicitly put them on the authorized header, then this problem would be solved, right? Because the browser is not doing stuff on behalf of you, and that would, you know, mitigate the whole cross-site request forgery problem. So they said, okay, you know, as it happens, we are just writing this spec called OAuth 2. So why don't we add specifically a flow for JavaScript applications so they can do the same API calls without cookies at all, right? So the IETF kind of like supported this, yeah? And of course, to get the token into your application, you somehow have to typically cross a security boundary, right? So like cross origin, right? And by the time the cross origin resource sharing wasn't invented yet. So they had to somehow find a creative, aka hacky, ways to cross these site boundaries. And that is what is called the implicit flow in OAuth. So just to show you very quickly, the way this works is basically the browser, the JavaScript does a redirect to a token, to an OAuth authorization server. And then the OAuth authorization server would reply with another redirect back and would send the access token across the boundary on the query on the query string, or the hash fragment, as they call it, yeah. Which you know, and then ultimately the JavaScript needs to store that token, which worked. What was a huge hack and caused all kinds of problems. I mean, sending stuff over URLs is just the leakiest way you can imagine how to send data across the internet. I mean, you know, that data ended up basically in, you know, log files, browser history, headers, in reverse proxies, everywhere, basically, yeah. And you know, it just didn't work out. And then, you know, fast forwarding a couple of years later, cross-origin resource sharing was invented. So suddenly you had a way to do cross-origin AJAX calls in JavaScript, and you did not have to abuse the URL to send that data. So they basically came up with a different flow, you know, and again, we don't have to go into details, but the ultimate idea is that you don't transmit the access token on the front channel, but that there's a back channel call, an AJAX call, that retrieves the token without having to use the browser, front channel redirect mechanism, so to speak, yeah, which was slightly better because these tokens were off the front channel, and that is where the real problem comes in. You can get these tokens into your JavaScript in many, many ways, yeah, but ultimately now they are stored in the browser, and that is the whole era of basically now cross-site scripting attacks. Yeah, which again was not really a known thing by the time, and actually the word cross-site scripting comes from an IE engineer at the time who found this problem, and the security people typically these days talk more about content injection, right? Because it's not just only about scripts, right? But if you are able to inject content into a JavaScript application, you can basically run arbitrary stuff, right? You can open new windows and iframes and JavaScript, and you can install web workers, whatever you can imagine you can do in the browser that you can do yourself, an attacker could do if they find some sort of vulnerability where you execute or render unvalidated input, right?
Yeah, and I can even remember like 10 years ago, like HTML encoding wasn't on by default in a lot of web frameworks. So it's like, luckily today, a lot of even front end frameworks encode user content, which is kind of nice. But there's always a reason to potentially turn it off, and there's like risk in that as well. So folks should really be careful. But I feel like we're at least in a better place than we used to be, so that's nice. But yeah, it's still pretty scary stuff.
Yeah, and the problem is it's just impossible to server-side encode all the content, because you know, like, encoding is always very context specific, right? I mean, if you want to put this thing into a text box, you have to encode it differently than if it goes on an attribute or on a query string. Or, you know, like, there are so many flavors of encoding that the server side probably doesn't know. And you know that there are things like DOM Purify, for example, for JavaScript, that has more intimate knowledge of the browser's DOM, right? And to do the right encoding. Still, you know, with all of that and Angular and React having, like, spending a lot of money and effort on that problem, it's still an unsolved problem, because, you know, like, when you look at the OWASM top 10 for the last 10 years or so, cross-site scripting is always like between 1 and 3. Like, it goes, sometimes it goes a little bit up and it goes a little bit down because a new thing comes along. But malicious code execution or content injection in browsers is a real thing. It still happens every day. And it's not a solved problem, regardless of what React or Angular is trying to tell you, really. Yeah, and again, you put in some arbitrary NPM package, right? They turn it off because they want more performance, whatever, and yeah, right? Yeah, exactly. So that's that, yeah. And the other scary thing is, you know, you maybe remember Spectre attacks, right? Where you could send, like, some weird characters to a server and start reading the RAM of the server. Google found out that this is also possible with valid JavaScript, yeah, to exploit these things in the browser. Yeah, like you start reading RAM of the browser process, for example, right? Which is, you know, I mean, long story short, I guess, is storing sensitive data in browsers is a risky thing, right? And that was the whole premise of this OAuth style approach, yeah, where you drive everything from JavaScript, and ultimately you end up with an access token inside of your JavaScript application and then start calling APIs. So you try to get rid of the cookie problem, but you introduce a whole new class of other problems, basically. Yeah. So that's kind of like the tension here, so to speak. Yeah.
Yeah, and again, it's like the way the web is, it's almost a feature, not a bug. Like, you don't know what the client is. You're passing it a bunch of these assets, and you hope that it's secure, you hope that it's doing best practices, but you just never know what the client is going to be. So it's like, yeah, it's not a trusted environment ever, basically.
Exactly, right? I mean, if they would use the latest version of React, and they would use content security policy, and they would use this and this and this and this, and trust the types and all the fancy things that they invent, maybe, yeah, it's pretty good, but that's not the reality. Yeah. Yeah. So you only have to find one weak spot where you can inject your code, and then it's game over, so to speak. Yeah. So that's the issue here, right? So yeah. So, you know, I mean, actually, I can show you a sample of that, actually. So we've been maintaining a JavaScript library for quite a while that did all of this, right? In that era where we thought that this is the way to go. Yeah. So that's an example. So Brock mainly was maintaining this JavaScript library. As you can see, there is no server-side code here, right? That's my whole pipeline here, right? It's basically just serving static files. So everything else is happening in JavaScript, right? So when I go to my index thing here, you see that I am configuring the whole OAuth, OpenID Connect stuff from within JavaScript, and it's all driven by the front end. Yeah. Yeah, let's run this. You know, so I can log in. It goes to a remote login server. I log in. I come back. Yeah, it works, right? So I have my tokens. Here's my access token. I have my claims, right? And I can start calling APIs, right? So that works, yeah. Of course, that stuff has to be stored somewhere, yeah. And that somewhere is, in this case, it's your session storage, right? So, of course, if I would now have a code injection vulnerability, it would be easy for the attacker that analyzed my application before to just reach into this place here and just, send them along via a query string or do whatever, right? I mean, there are multiple ways how they could exfiltrate that data, yeah? And then, obviously, an attacker possessing the access token can now do arbitrary API calls against my backend, yeah, which is bad. Yeah,
yeah, very bad. Yeah.
yeah.
You know what's funny too? It's like nothing is secure. Like a good example of like if people are playing Wordle, you can just find the answer in session storage, right? Like so if someone was to inject something into the site, they can just read anything like you were saying. It's like nothing is secure.
Up to this point today, I don't know what these pictures mean if somebody posts them on Twitter. So I don't know, Wordle. I heard about it before. Someone paid a lot of money for buying it, right?
Yeah.
Yeah, sure. I mean, you cannot hide data in the browser. It's impossible.
Mm-hmm.
Yeah. Regardless how fancy you get, yeah, with web workers and like the crypto APIs where you never get access to the private key, but only the public key. It doesn't matter, yeah. If the attacker can inject the code in your browser, they can do the same things as you can do, which is good enough.
Yep.
Yeah. And you can mount arbitrarily complex attacks, really. So yeah, I mean that would not require a complex attack here. It's here in front of you. All you need to do is get it from there and send it somewhere else and party on. Yeah. So that's one thing, right? So the OAuth people thought about this, right? Said, okay, that is not a good place. So maybe these access tokens should be short-lived, right? But if you have short-lived access tokens, what if you need long-lived access? Let's say your access token is valid for only 10 minutes, but what do you do after 10 minutes? You still want to call these APIs, and this thing in OAuth called the refresh token is even more dangerous, right? Because the refresh token is a long-lived artifact. So they came up with this mechanism they call silent renew. Yeah, so where basically you could bind the access token lifetime to the session lifetime in the browser, kind of. Yeah, so when I say renew token here, right? You see, I'm getting new tokens, and guess what? Yeah, no flickering. So my goal was achieved here, right? Yeah. But if I have a look at how this actually works, yeah, if I go to inspect, you see when I click the renew button, so what happens is for a moment, like the secret weapon of the web developer, an iframe, is used, right? So basically, you see that for a split second there will be an iframe opening, and that in that iframe we basically do a token request, yeah, to get back a new token to replace the old one that might be expiring soon, yeah, and the beauty of that mechanism was that this only works if the sign-on session with the token server is still in place, right? Because the whole iframe mechanism relies on the fact that we're sending the cookie to the server, and then if the session is still valid, only then we're going to get back a token. And if the user is logged out in between, this will not work anymore. So at least there was something that limits the life, the duration, how long an exploit could be mounted, I guess, yeah. So that's one thing where they utilized iframes in this architecture. The other one you can see here, there's another iframe here, which points to a very special endpoint on the token server called the check session endpoint. And this is used for session notifications, right? So my front end probably wants to know when the user logs out from the backend, right? And again, this is all my assumptions here are like for typical business style applications, right? Where you log out, you want to make sure that you clean up the data and so on. So this iframe here is used basically to have a channel open, right, to the logon system to receive server-side kind of notifications from the external system back down to figure out that we logged out. Yeah. So I can show you that. So when I go to here, yeah, to my logon server, and I log out from here, then magic happens, yeah, over this iframe, there's a notification being sent down, and I'm signed up. Okay,
yeah. Yep.
So that's basically like that. We are now in the heydays of the token era, right? So everything was moving to tokens. Lots of things were invented to facilitate the token lifestyle in the browser, so to speak. Yeah. So these are all the things, right? That people did and people still do, right? And now I'm coming here and telling you, yeah, you're doing it wrong again, yeah, because of all these problems here. And one of the, I guess, oh, sorry, that's the inception mode. One of the things, let me forward a little bit to here, is now what's happening right now is that the browser vendors are doing a lot of changes to their browsers, yeah, and that is typically under the umbrella of privacy protection, right? So there are a lot of privacy problems in browsers with like ad trackers and all of these tracking networks in general, and the problem is that these tracking mechanisms, they look indistinguishable to the techniques I've just shown you, like redirects over site boundaries, cookies coming back, cookies flowing in hidden iframes back and forth, all of that stuff. That's exactly what OAuth is utilizing, but that's exactly the same technique as these ad trackers utilize as well to track you across site boundaries. Yeah. Mm-hmm. So many browser vendors already did make changes to their browsers or will. Yeah. So as always, Chrome is the biggest player here. They announced these changes for next year. They actually wanted to go do them earlier already, but they got basically told by governments that they can't because it would break their websites. But the one company that went, like the one relevant company, I guess, that went ahead and just implemented these changes is Apple in Safari. So basically, the changes is that they will not send cookies across site boundaries anymore in an iframe. Yeah, that sounds like a simple change, but it is breaking everything I just shown you. Yeah. Let me actually, before we move on, just quickly show you that. So when I take the same application, yeah, and open that in Safari, and I log in, right? Well, let me log in here. Now, what will happen, what you will see in a moment is now I'm coming back to the application, right? It opens this check session iframe to wait for server-side events, but since the iframe does not send a cookie anymore, the server will see an anonymous iframe request and will say like, hey, I don't have a user, you are not logged in, yeah? And this will just break the application straight away. I'm immediately signed out. Mm-hmm. Right, and the same, of course, will happen for the renew token mechanism because there's no cookie in the iframe. I can't get tokens anymore. So, you can't ignore this problem. So if you have an application today that is using this approach, it will not work anymore in Safari and next year. And if that is, what you're waiting for next year, it's probably not going to work anymore in Chrome as well.
Yeah, I mean, the interesting part is for a long time we had version browsers like IE, like for the longest time government agencies were just like, we're staying on IE7 forever, like we're not moving. But now the browsers are evergreen, like this is a problem that a lot of IT departments are just going to have to figure out how to solve because they probably don't have the luxury of just freezing versions of browsers. It's like, you can't ignore this time. It's coming for you.
I'm using Brave for 1 or 2 years now, mm-hmm. Which is basically Chrome, but with all the additional, tighter security settings. And this wouldn't work in Brave either. Yeah, and it's always funny when I try to log in to Teams, for example, with Brave, and they pretty much tell me like, hey, your browser is too new. Use an older browser, please. Yeah, it'll work great with Chrome. And yeah, lo and behold, it does. Yeah. But yeah, I mean, it's funny, right? I mean, we went through an era where the browsers were not new enough to support all the features you want to use, and now suddenly they are too new because they now added these security features which applications exploited. Yeah.
Mm-hmm. Yep. So, exactly.
Yeah. So I think we will see more of that very soon. As I said, Firefox, I think, has this high security settings where if you turn this on, it will also not work anymore. Brave by default doesn't work. Safari doesn't work anymore. And Safari has a 15% market share, right? And then actually Chrome comes and actually I was at this OAuth security workshop last week where this was a big topic, right? Because this is breaking OAuth in many ways, yeah. And there's a dialogue going on between browser vendors. I mean, finally, because normally browser vendors just do whatever they want, yeah. But there's a dialogue going on between the identity people and the browser vendors, and it turns out they don't even speak the same language, basically, yeah. Yeah, and for browsers, it's, Chrome has Google has a different view of the world than the OpenID Foundation. Yeah, that's for sure. But the thing is, Chrome will implement this at the Chromium level. So it's not a Chrome feature that the whole browser, the cookie thing, it's baked into the engine, right? So every browser that depends on Chromium will get this behavior as well. For example, Edge, yeah, or Brave. Brave has it already because they added it on top. But so it seriously will break web applications again, right? We just changed them from using cookies to tokens, and now suddenly the tokens don't work anymore either because, so that's why I said in the beginning, I feel bad for these people. It's you can't rest. Yeah.
Yeah. There's no rest for security folks. Keep working.
No. So now let's switch our focus a little bit on the good browser changes. And that is definitely, the whole thing started with like, hey, the cookie approach has its problems because of cross-site request forgery, right? So in other words, if we would fix cross-site request forgery, couldn't we give the cookie thing a second look now? Yeah. And that's exactly what happened with this thing called same-site cookies, yeah? And the idea with same-site cookies is that, the problem I showed in the beginning, yeah, like you're going to server 1, get a cookie, and then you go to server 2, and server 2's front end makes a call to server 1, and the browser happily sends that cookie across the site boundary. Why don't we fix this problem, right? So maybe the browser should be smarter and saying only if that thing, you should only send that cookie to server 1 if you're actually originating from server 1, and if server 2 tries to do that, it just doesn't flow across the site boundary, right? That would be actually very helpful, and you have to ask yourself, why wasn't it like that all along? Yeah. A very obvious design choice, yeah. And that is what is called same-site cookies. And again, when they introduced them, it broke the web, right? Because many people were relying on the fact that cookies travel across site boundaries. All these portal-style things, right, where you have iframes, which you load. You load applications from all over the place and iframe them together in a single thing. Mm-hmm. That typically relied on the fact that cookies were traveling cross-site. Yeah. So same-site cookies basically fixes that problem by basically saying, hey, so there are 3 modes. Yeah, like none is opting out of this. There's lax, which restricts the cookies cross-site if you're doing post, and strict, which restricts cookies flowing cross-site if for both get and post. Yeah. And lax is pretty much what MVC always did with the anti-forgery tokens, right? When the post back comes from the browser, it makes sure that the origin is coming from the same application, so to speak. But now it's built in the browser. You don't have to write code for it anymore, and the browser is enforcing this automatically. Yeah.
Yep. Exactly. Yep.
Which is great, I guess. Yeah. It definitely helps with that, and of course, by definition, the security boundary now becomes the site. Yeah, and many people are maybe not aware what a site really is. So the browser has origins, which is much stricter, which is like the protocol, the DNS name, and the port, and anything that doesn't match all the three is cross-origin. Whereas the site really is the top-level domain becomes the site, like let's say mycompany.com, right? Is the site, and then all of your subdomains are in the same site. So cookies can flow between the subdomains, but they can't flow from outside of mycompany.com. Yeah. So that's what you get from the browser by default. And obviously, this only is useful to you if you trust all your subdomains, right?
Yeah.
Right. So if you have a huge company and you have like hundreds of subdomains, and like, can you really be sure that whatever the CRM guys are doing on CRM mycompany.com is as good as banking.mycompany.com? I don't know, right? So it doesn't fix all the problems, but by definition, by enforcing the same site boundary, it fixes cross-site attacks. Okay.
Well, don't you have a good story about how someone took a subdomain from actually like a big company and was able to exploit a subdomain, like did a subdomain attack?
Yeah, so there is a known attack called subdomain takeover, where basically, let's say you find a way, right, to run code on a subdomain that relies on where the only security measure is the same site sandbox, right? And the way, long story, but basically what happens is, and I think everybody, whoever did Azure or AWS in their life, they know this, right? You knew up an Azure website, you set up a custom domain for it, right? And the way this works is you go to your DNS server and set up like, myapp.mycompany.com that points to blah, 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 azurewebsites.net. And whenever you shut down the Azure website site and delete it, right, the name becomes free again. And all the attacker needs to do is register a new Azure website with the same name, right? And your DNS server still points to it as a subdomain, and suddenly your code runs in the subdomain of the company. Yeah. I mean, it's not that easy anymore because that is a known problem, and that there are these text files, text DNS things you have to exchange now. But this used to work at some point, and this was a real attack. Yeah. Yeah.
Wow. Yeah. Scary stuff.
Do we have any questions, by the way?
Yeah, mostly. Well, first of all, Lars says your book was definitely not a waste of time. It taught me all the basics about claim-based security and federated identities. So
that's a different book, actually. The one I was mentioning was the ASP.NET 2 security book, which coincidentally was published 3 weeks before ASP.NET 3.0 got released, but that's a different story, which doesn't make it a bestseller in the shelves, to be honest. But
well, somebody appreciates your writing, so you can take that as.
So that book, I totally forgot about this. Yeah, that was a book we made in cooperation with Microsoft. It was called The Guide to Claims-Based Identity and Access Control, I think, and that was actually a really useful book. Yeah, like didn't take that much time to produce it. We brought good people together in a room and we brainstormed and basically wrote it, and that helped, I think, many people to get up to speed with this new thing called claims, which was new and a little bit, how should I say, complicated, and just a new thing that required some rethinking, I guess.
Yeah. I mean, everybody should be writing, and I'm really happy when people write blog posts, but especially happy when people put in book form. So again, thank you. Like, it's just awesome for the community. Here's another question. And this is probably something you'll get to later in this talk, but maybe you can think about it. Harris asks, should I prefer same-site cookie over JOT token for Blazor apps where I use hosted WASM model? So it's like,
yeah, we'll get to that. Yeah, that's basically the last part of the talk. Yeah.
And I'm trying to see anything else. If you implement a backend for Frontend with Blazor WASM and Azure AD, you only register one Azure Active Directory app. In the Microsoft Blazor WASM manual, you register two, client and server. Why is that? But you're probably going to get to that. Yeah.
besides the usual weirdness of Azure AD, I guess there are other reasons.
Well,
we'll get to that, yeah.
Well, here's one to think about, because I don't really know the answer to this one, but maybe folks can kind of discuss it in chat. Is C# considered to be more secure than JavaScript? If so, why? I mean, languages are languages. Like, it really depends more on like the context where that language is used more than, say, the language itself. But I don't know if you have any thoughts about Dominic.
Yeah, you're right. I mean, I guess C# is a little bit different because it was never it typically doesn't execute dynamic code, right? As opposed to with eval, the eval statement in JavaScript, for example, which was designed exactly for this, right? And there were frameworks relying on the fact that they can do like meta programming, right? They first write the code and then execute it. But yeah, I mean, the main problem is not JavaScript, it's not Angular, it's the browser, right? You're basically putting your code in the most hostile place you can imagine.
Yeah,
right.
The web is really, it's really Thunderdome, like.
Right. If we would write our applications in C# these days, there would be a way to inject C# code into C#, I guess. Yeah. So no, I think JavaScript is a weird language, I think, but that is not the reason why it's insecure.
I mean, especially too, like for like C#, there's like Cecil, which lets you like compile C# on the fly. I've heard people letting folks type link statements into text boxes and letting them run that on the server.
Absolutely.
So
yeah. I mean, I've seen attacks where you basically a link statement, like you can execute code in a link statement on the server, and these all these Microsoft websites that let you try your code, they spin up Docker containers for each line of for each thing you submit. It runs in a Docker container because that gives them the security boundary, because it's you can't control the input,
Yeah, and even Docker containers are not technically secure. Like, there's ways to break out of them. So security is hard, and that's why we have professionals like you to kind of like slap our hands when we're about to do something really stupid. So thank you for.
I mean, to answer the question, it's not a programming language problem, really. It is. It is. It's just very hard to validate input. Yeah. And the fact that we can happily execute that code is just huge. Yeah. A huge problem and hugely exciting as well.
Well, so I know folks are asking about Blazor, so let's continue, and you're going to get to that soon.
Okay. So yes, exactly. So long story short, so if you think of these two eras as extremes, like cookies only and tokens only, I guess it should be pretty soon become apparent that maybe it's somewhere in the middle is the truth, right? So, and there is a very interesting spec called OAuth for browser-based applications, and ultimately, that's how these that in these specs the ASCII art looks like, but basically, ultimately, they propose either, like you're having applications that don't have a backend, and that would be the pure JavaScript-based approach, or you have an application with a backend, right, where you do all of your UI stuff in the front end and the security in the backend. They are two fundamentally different architectures, and you choose really which one you prefer. But the RFC is very explicit that for applications dealing with sensitive data, you probably should use the backend approach, because that's where you can store the sensitive data. You have to use those tokens somehow and store them somehow, but the browser is definitely not the right place, right? And there was this pipe dream, like a spa. All I need is a static file server, right? A CDN that hosts my JavaScript, HTML, and CSS, and then now I can, write real applications. That's not the case, for more complicated stuff. Wordle may work like that. But if you're building like a real business application with authentication, single sign-on, API access, blah, 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 I don't think that that's going to work. Yeah, and I wrote this blog post 3 years ago called "Spas Are Dead," and this got picked up by Hacker News, and I was like heavily flamed on the internet that I don't know anything about spas apparently. If these guys would have read like the first sentence of the blog post and not just the headline, they would have probably noticed that it was a joke. But yeah, spas in the sense of the standalone application just loaded via the browser, I think, is a dead concept from a security point of view. Spas as the UI technology that people are expecting these days is, of course, not a dead concept.
I think the promise for spas was really like based on financial reasons, right? Like people like getting a server was expensive, but like static hosting, oh man, I could save a ton of money. But that dream is dead, folks. Probably time to. Plus, right now there's a lot of cheap hosting even for like backend services, right? So Azure can be very cheap. DigitalOcean. One of my new favorites is like Railway. So there's like a lot of options out there. So
and again, I mean, we have to set this in context, right? I mean, there are many types of spas that don't need this security architecture, and for them it's totally fine, right, to use the CDN approach and so on, yeah. But for business style applications that deal with security, sensitive data, authentication, and all of that, I think you need that backend to help you out a little bit.
Yeah, I will say though, like the point you're making is like there might be some spas that have completely client-side experiences, but the truth is in our world, like the inevitability of people wanting to be able to log in, save that data to a remote service, maybe access it from different machines. It's almost inevitable that like even an isolated spa will eventually evolve into something that does contain some type of sensitive information, right? So
sure.
I think folks should probably be aware that when they're building something like that it may evolve, right?
Yeah, I always give this example of if you're just building an application that does some restaurant rating, yeah, maybe you don't need a fully fledged security architecture, but the moment somebody exploits that, yeah, maybe you start needing that, yeah. So yeah. Anyway, we can skip over this and over this as well, but basically there were some different flavors of BFF, and I don't want to go into detail here because that's a distraction. And again, there are other recordings of this talk, but the ultimate idea is that, as you can see here, the browser is the browser, and when it wants to start doing token business, it basically goes to the token server, but the token server will not come back to the browser to deliver those tokens, right? It will basically be on the application server where all of these tokens are managed. Yeah, that is the whole idea. Which and the result of that architecture is that your browser will never call your APIs directly anymore. Yeah, which is what people say like, oh, that's not cool. But that's just the consequence of that. Yeah, your application server will proxy those API calls or handle those API calls server side, because the browser does not have access to those tokens anymore, and they should not have, because there is no secure place to store them. Yeah. So that's kind of the idea, that the backend for Frontend, yeah, and they are tightly related to each other, so they should be best friends forever, I guess. Is taking away much of the security stuff, but also, and that's what the feedback we're getting from developers is, also much of the security complexity. Yeah, so the JavaScript developer does not need to deal with tokens, does not need to deal with silent renew and session management and token refreshing, and that's complicated stuff. Yeah. That should not be the concern of the front-end developer. That should be the concern of some library that you're plugging into your backend. Yep, exactly. Yeah, that's really what it should be. So let's say you would build a BFF, like a front end, a back end for your ASP.NET based application, right? I mean, 75% of the building blocks are already existing. Yeah, like you have your Microsoft ASP.NET Core, OpenID Connect and OAuth handler. And you have session management, which boils down to cookies, like a sliding expiration cookies and all of these things. Then we can help out a little bit with some open source projects for token management. Then we have how do we call our APIs? And then ultimately you have UI assets that you have to deal with. And in this model, if that is your your web model, it wouldn't really matter anymore if this is a MVC UI or a Razor Pages UI or an Angular UI or whatever UI, right? It just becomes a UI. And one type of UI is more like on the browser, and the other type of UI is more like on the server. But regardless, the security bits are always running on the server, and that is to be very specific, the OAuth handling, the session management, and the token management, right? And then maybe you don't even need to call cross-site APIs. So that is kind of like an optional part here. So in my mind, you have two parts: all of the security stuff on the server, and the UI is what's running in the browser.
Yeah, and it's the nice part too is like a lot of that server stuff is very like battle hardened technology, right? It's like it's mature. There's a lot of people using it. So whereas still a lot of stuff on the client is changing and evolving, like you've kind of shown throughout this whole talk.
That's a very good point. Yeah, I mean the Microsoft OpenID Connect server-side plumbing, is really battle tested. Yeah, I mean it's used all the time. It has been evolved over a couple of years, and this stuff is working. Yeah, that I have much more confidence in that than some NPM package I pulled from somewhere into my JavaScript front end that it claims to be secure.
Mm-hmm.
Yeah. So just full disclosure before somebody says, is this a product pitch here? No, it isn't. It's true. I have worked on a product that implements the whole thing. But you can do it yourself. It probably, this thing is cheaper than the time you spend yourself, and it's also open source. So if you want to have a look at that and so on, it's not black magic, yeah. But one thing we did at Duende when we made the transition from free open source into a commercial license is we introduced this thing called a fair trade software license. So basically all the software we are producing is free for any individual or company that has less than $1 million revenue a year. Yeah, which, if you're a hobbyist or you just want to learn, feel free to use it. If you are, just starting up and you need that software to implement your stuff, feel free to use it. And if you get successful and make more than 1 million in a year, I think you can just afford that. Yeah, that's kind of like the idea here.
Yeah, I mean, I think it's fair. Not to make a pun, but I think it's fair, and I think Identity Server is one of the best open source projects the .NET community has. So again, thank you folks for building it and making it accessible to folks who want to take security seriously. So yeah, folks, definitely check it out. It's awesome.
Thank you. Yeah. So, coming from that open source world, we definitely were struggling really hard. So like, how can we, quote unquote, make the world a better place by catering to both communities, right? Like the commercial ones that need a real company and support and documentation and, all of that, versus people that, don't have that money to spend and, just want to use our stuff. Yeah. Mm-hmm. So that, I think, what we came up with, which is, we think it's the right way to do it, and many more should do it like this. I think don't give away your software for free to the big companies. Make them pay, and the small companies, they should benefit from actually the money flowing into your company that you can improve the product. Yeah.
Yep. Yep.
Cool. Anyways, that's that. So As I said, so maybe, you know, we don't have to go into all of the details. So let's switch back to code. Where are we? Let's just go here. So you see, basically, we have a front-end host which runs the front-end plus the front-end supporting bits, and then we have a back-end host again as well, if you want to call APIs, you know, cross-site. And if you look at the startup, yeah, it basically looks like a server-side web application, right? It has authentication here, it has cookies, it has OpenID Connect. But now, you know, we use same-side cookies. Yeah, we use all the new bells and whistles here. And then it basically serves static files. Yeah. So, so if I run this, we can just see how that looks like. Right, so it's a JavaScript thing. So how do we allow the JavaScript basically to trigger those server-side features? And that is basically by our BFF plumbing just exposing a couple of local endpoints. You see, basically, if you want to trigger login from JavaScript, you see that there's basically there's a local /login endpoint at the application. And when I click this, you know, the server side takes over, does all of the security stuff, creates the OpenID Connect requests, and I'm ultimately getting redirected to the login server. When I come back, you know, I'm logged in, and same goes for logout. You see that there's a local logout endpoint, which then does all of the server-side logout stuff. And the third endpoint we are exposing is just a user endpoint, so that you can expose the server-side session details to the front end, right? Maybe you have claims that you want to use for personalization, yeah, who want to know who the user is, right, or what their favorite color is, whatever, right? So that's up to you. And as you can see, my UI skills are not, you know, I'm better at security than UI. So there's that.
So somebody's asking a question, KO. For me, BFF was a way to give front-end specific APIs for domain purposes.
Yeah. Hold on to that thought.
Yeah.
You're right. That's actually where I heard the term first. The very first time I heard this term BFF was not in a security context. Yeah. And that's many, many years ago. So that's nothing I invented, or that was invented in the context of security. You are absolutely right. That was came up with this old microservice architecture, right? That there's a domain-specific backend for a micro front end that exposes certain APIs to the front end. So that is, so when you Google for BFF or backend for frontend, maybe that gives you better results than BFF, I guess. You will see a lot of that, right? But in the security space, and you know, if you think about it, you are exposing very domain-specific security endpoints for the front end. Yeah, that's kind of the same idea. Yep. So anyway, so the first thing you would do in a typical BFF is that you are exposing same origin endpoints, yeah, to the front end, yeah, right? So we want to live in this very strict sandbox of same origin protection, right? So that's why we have a /login, a /logout, a /user. So you can, you know, basically all of the stuff that the front end has access to should be just a matter of just calling a relative endpoint to the backend and not having to cross a site boundary, not having to cross a domain, an origin boundary, and so on and so forth. Yeah. And then you log out again, right? And you're done. Yeah. So that's basically kind of like the most basic of a life cycle, so to speak, right? So that's basically skipping all of that. You know, basically you have a login endpoint, you have a logout endpoint, and you have a user endpoint to get like the session information of the current user. By the way, I should make you aware that there's one thing people use sometimes for the session endpoint is to poll if the user is still logged in on the backend, for example, which has an issue, of course, if you're having sliding expiration cookies. Starting with .NET 6, we proposed a new feature that you can dynamically turn off sliding for a given request. So basically, you're making a backend call, and then by virtue of having a special query string parameter, we can tell the cookie plumbing on the server that for this special request, the session should not slide, right? Which is quite nice, because now you can actually really use it as a polling mechanism. You're like, every minute or so, is there still a session? And you're not messing with the session, so to speak, right? So you can use that as a way to figure out how long the session will last, or will still be valid. And actually, if we run this here, you see that when you query the user endpoint or the session endpoint, we have in here that we inject, which is called expires in. So you know how long, from a server side point of view, this session will still be valid, for example. Yeah. So if you want to do some more clever things on the front end with activity, like inactivity timers or things like that. Yeah. Anyways, so yes. Oops, sorry. Here we are. Right. So yeah. So APIs, right? So that the front end, as I said, depends on the way you see it, but the front end basically wants to call the back end, yeah. And when we went through this exercise of eliminating the tokens in the front end, we started refactoring the applications, and it became apparent, yeah, that there are probably two types of APIs you want to call. Some of these APIs, they might only exist exclusively because your front end needs them. Yeah, and that's what I like to call them local APIs. And if you think about it, they could live in the backend itself, right? In the BFF itself. There's no need to do a complicated cross-site call for that. Yeah, if your front end is the only caller of this API, then what's the point of putting it into a shared location? Yeah.
Yep, exactly.
And actually, the OAuth for web apps spec I mentioned earlier at one point had a paragraph in there saying like, hey, if you don't, OAuth was made for calling cross-site APIs. If you don't call cross-site APIs, you might not need OAuth, which is funny for an OAuth spec. Yeah. And this was removed at some point, but you can go back in history and see the diffs, and it's somewhere. Yeah. But yeah, they're absolutely right. Yeah. If all the APIs you're calling are exclusive to your front end, you don't need to put on the burden of doing this complicated access token, refresh token, whatsoever dance, right? And so when we go back to the sample app here, of course, I'm old and boring, so all we came up with was a to-do controller. Yeah, but if that is, if this to-dos API is only used by this front end, yeah, what's the point of putting that into some other server and increasing all that complexity, right? So, and coming back to this comment, yes, that's a domain-specific API for that front end. It's the to-dos list, right? And stop talking soon. If that's on my to-do list, yeah, I can just do that, yeah. No OAuth, no access tokens were needed to make this interaction, because this is purely protected by the front end, back end with the same site cookie. And actually, we're doing a little bit more than just same site cookie. We're also adding, because I said earlier, right, the same site cookie is fine if you trust all the sites, all the subdomains on your site, right? But as a default value, I think it's even better to say, like, I only trust my origin, yeah? And so there's a neat little trick which I learned from a friend of mine, that by adding a static header to your AJAX calls and requiring the cookie to be sent, at the moment you're crossing an origin boundary, it will always trigger CORS, no matter what. Doesn't matter how that thing gets triggered, via image tags, via postbacks, via AJAX calls, it will always trigger CORS. Yeah, and it doesn't even need to be like some complicated dynamic value. Just the existence of a non-standard header will trigger CORS, which means if you are enforcing the existence of this header, you are, with very little effort, are not only sandbox to the same site, you are also sandbox to the same origin, which is a pretty strong sandbox.
Yeah, that's awesome. That's a neat trick.
Yes, and it will, even better, it will trigger CORS pre-flight requests. Yeah, and now remember when I said earlier the research about these Spectre attacks against the browser, where you can read RAM, right? With pre-flight requests, that the data will not even be in the browser's RAM because the browser will first ask for permission before it will get the data. So even if that Spectre thing should be a thing, right? The data is not in the RAM of the browser because pre-flights were used for CORS, yeah, which is blew my mind when I realized that actually, yeah. So for the simple cases, yeah, where you have your front end, you have your back end, you need authentication, but you're only calling local APIs, no OAuth needs to be used at all, right? There's no need for that, yeah, and that's just what I showed. Now, if you have a more complicated architectures where you actually want to call remote APIs because you have APIs which are shared by multiple front ends, for example, or multiple clients, you have to make up your mind, right? I mean, and that's where the BFF idea comes from in the first place, as someone pointed out. You could have a local API endpoint that is offering a domain-specific API surface and then turns around and calls some other API to get the data and then presents that data in a front-end specific way, right? Mm-hmm. Now, for calling this other endpoint, you probably need OAuth, right? Because you want to delegate the identity of the front-end user to that remote API. That remote API is already protected by OAuth. So yeah, so now the BFF becomes more useful by being able to manage those tokens, yeah? But what you're ultimately building is a reverse proxy, right? So different styles of reverse proxy probably would be, as I just said, you're writing a completely new API and turn around, get some data, and do that back. We had the feedback, especially for refactoring, that they started reproducing a large API surface just for the sake of being same origin. Then you could think of, do you want to have more like a general purpose reverse proxy approach where you basically expose a whole API that is living somewhere as a local endpoint in your BFF. And that's where we started researching how that could be done. And there was this thing called ProxyKit a couple of years ago by our good friend Damien Hickey. That was like a developer-focused reverse proxy. And then Microsoft picked up the idea and turned it into YARP, which stands for yet another reverse proxy, which is kind of a funny name. Yeah. Yes. So that's, if you're having that scenario, then YARP is definitely a thing. Yeah, or could be a thing for you, could be, other approaches as well. So long story short, we have basically added a simple helper here. So let's say you would want to use, you remove that to-do API from the front end and put it on some shared server, right? All you probably would need to do here is, you are removing that local endpoint. So I guess I would remove this here and replace it with a call to YARP. And again, YARP is it's a reverse proxy API, right? So you can wrap that in whatever style you like. So we just added basically a remote BFF API endpoint, which basically says whenever something comes in on the local /to-dos endpoint, we're going to proxy that to a remote API that lives on this URL. Oh, and by the way, we require the OAuth access token of the currently logged on user so that this remote API endpoint can do its authorization. And it also enforces the anti-forgery protection I just mentioned.
That's awesome.
Okay.
Very
basically cool. Now, all I have to do is bring up my API here, right? So I'm running the backend now. And I'm restarting the front end. And you'll see our front end doesn't know anything about these changes, and I can start continuing using my front end. But now we are using a totally different API. protected by OAuth, running on a different server, and so on and so forth. So yes, that's basically in a nutshell what the BFF pattern gives you. It simplifies the client. It takes away all the security burden from the client, and moves that, of course, the complexity has to go somewhere. It goes to the backend, right? But as we've seen, you can package up all of that heavy lifting in, like, boilerplate, building blocks, so to speak. Yeah, on the back end. And yeah, in my experience, the application becomes simpler because we can move this complexity to a place where we can use pre-existing frameworks or our own frameworks, or the things you build at your company or whatever.
Mm-hmm. Yeah, this kind of leads into a good question from Derek Irving, who says, does the BFF pattern mitigate any changes the browser vendors may make in the future? The answer seems obvious to me, but I'll let you answer it, Dominic.
Yes, basically by saying we limit our communication in the browser just to my own backend, yeah, it's basically you are now in the sandbox the browser vendors want you to be, right? That the browser vendors feel uncomfortable if you're doing too much cross-domain, cross-origin communication. That's why they start restricting this. Yeah, but with this approach here, basically the only communication partner my front end has is its own backend on the same origin, right? And that is pretty much, as I said, the security boundary that browser vendors like you to be in. Yeah.
Yeah, and Marcus has a follow-up question, like, what's the best way to secure the session between the browser, like same site session cookies, restricted to the same host? Like,
yes. So that's basically what this thing from Microsoft does, the cookie handler, right? We set it to same site mode strict, which means that's the highest mode you can have. That might not be compatible with your application because now GET requests, cross-site will not have cookies anymore. And if you rely on linking maybe between sites, that might not work. But you can, if that's the problem, you can go to lags, right? So strict basically does GET and POST requests, and normally an application should be fine with GET requests because, as we all know, GET requests should not change system state, right? So anyways, and the host prefix browser, it protects you against some other subdomain related attacks. So yeah, all of these things are in there. So that's what we get for free, right? And then in addition, we add this trick with the static XCSRF header. And actually, so in here, when you scroll down, this little extension method here, as BFF API endpoint, what this basically does is it enforces the presence of this static header. So if somebody calls you without a static header, they can't call you. And if they have to add a static header, it will trigger CORS, which then will, fail at this level, which is pretty cool, yeah.
Yeah, very cool. Yeah, Peter Morris has a question really about like token management. I don't know if it's related to BFF, but I'll ask.
Yes, it is. Yeah.
If new permissions are granted to a user who's already logged in, do they have to wait for their token to expire, or can they renew before the expiration of that token? I think, yeah, go ahead.
This question kind of implies that the permissions would be in the token, right? Which would be a clear anti-pattern, right? So that the token is not about transporting permissions. It's about expressing who is the client, who is the user, and which APIs is the client allowed to call. And everything else beyond that is a business logic / authorization logic problem at the endpoint. I know many companies abuse access tokens to transmit permissions, and they run in exactly those problems that if you change a permission, it doesn't become effective unless the user logs out and logs in again, or things like that. So that's kind of like an anti-pattern from my point of view, and you are basically violating a separation of concerns principle here.
You know what's funny about that is like the idea of clearing the cache in the browser has become mainstream, like a mainstream concept, which I find funny because it's like it shows kind of a failure in our technology in a way that like consumers know what clearing your cookies means.
Right. It's as we call it, developer logout. Right.
Yeah.
Yeah, so maybe just because many people have token management. So when you said token management, what I typically think about is more like the token lifetime management, right? Like as I said, X tokens have limited lifetime, then you need a refresh token and so on. This is unfortunately not built into ASP.NET Core at all. I proposed this many years ago to Microsoft, and they just didn't pick it up for whatever reasons. Anyways, if all you care about in your, and it doesn't really matter what type of ASP.NET based application you're writing, if that's what you care about, there's an open source project which is not tied to our BFF thing at all, which just takes care of this one aspect, namely token management or token lifetime management. So that's something you might find interesting. Yeah.
Yeah. And
maybe the last thing, is because probably some people are here because of this, is let's have a look at the Blazor thing. Yeah. Let's actually open the repo because there are some samples in there. And I don't even need to run them, I guess. It's more like the style. So if you open the repo, you see that there's a samples folder in here, and there are a couple of samples, like Blazor, .NET 5, .NET 6, JavaScript, and so on and so forth. So the funny thing is, a Blazor application is, it's the same, right? I mean, I used to joke that, one thing is JavaScript and the other thing is binary JavaScript, right? It's the same thing, yeah? It's the same architecture. And Microsoft already has actually, and I'm glad they do, a template that they call hosted Blazor WebAssembly, I think, yeah? And what that gives you when you run this template, it gives you 3 projects in one solution, yeah, where one is basically the server side, which is the hosting infrastructure, which is your BFF, yeah. It gives you a client side project, which is the UI only, and it gives you some shared thing, because the weather report is very important as always, so we need to share it somewhere, yeah. But if you look at the server project, you open it and say, oh my God, that's just ASP.NET Core, right? It's exactly this, yeah. It is very, very similar to just what I've shown you with JavaScript, yeah. It has OpenID Connect, it has cookies, yeah. It has endpoints, right? And it has the Blazor server plumbing, and it. That's your BFF, right? It's the same idea. You have a hosted backend, and basically, I should say Microsoft has 2 flavors of these templates, right? Where the one is the non-hosted version, which is basically doing it exactly like I said earlier you shouldn't do, where the tokens are managed in the browser itself, and they have the hosted version of that, which gives you at least a starting point to do it the BFF style way, so to speak. Yeah. Actually, I don't know. That's off script now, but let's see if I can run this.
Just pray to the demo gods. Just pray.
Yeah. So let's run Blazor 6 server. Let's see what happens. Hey, okay, so same idea. So when I click the login here, all it will do is the Blazor will basically just execute a local endpoint called /login in the same application. Okay, so it should give us the same results. Let's see if I'm right or wrong about this. Yeah, but here's a login page, and if I actually do another developer thing, I should now get even CSS. Excellent. So I can log in, right? And here we are. Yeah, so here's my session just now from a Blazor point of view. Right? Same thing you saw before in JavaScript when I said give me the current session. You see again who's logged in, right? And how long will the session still work and some other stuff. Yeah. And then I guess I can even fetch data and my UI, that all plays nicely with the Blazor built-in controls, right? Where they have this authentication state concept and so on. So yes, and then
I think that answers somebody's question. Does the BFF completely take over the communication with the identity provider, Azure AD, Google, or does the front end still handle the authentication? The back end is everything to the front end, right? Like, so it handles everything in this case, right?
Right. The front end just says, I want to log in, yeah, by handling control over to a local login endpoint, and then whatever authentication handler you have configured in the backend for ASP.NET Core, this will then do the actual login. In this case, it's OpenID Connect, right? Using Identity Server, but that could be Azure AD, it could be whatever you want, right? I mean, whatever ASP.NET Core supports, and they support a lot.
Yeah. And Dolly just asked, like, what about distributed cache? Yeah, anything you can use in ASP.NET Core, you can use for your backend. So I think that's the power of BFF, is like, you're not limited by the client, you're limited by what you can do on the server, and what you can basically do on the server is anything, right? It's your sandbox. It's your place where you can do really anything to provide functionality for the front end. So yeah.
Yes, and yeah, I mean, the same frameworks do also exist for like Node.js, for example, right? I mean, same idea, yeah. And you have a very, very rich ecosystem in Node.js, and you have a very rich ecosystem in ASP.NET Core. Basically, you choose the backend technology that you prefer, I guess. Yeah, the front end doesn't need to know about this. Yeah. So yeah, it's basically offloading that. And maybe the last thing I want to show in this code base here is the power of YARP, right? So I've shown you a very simple YARP use case, which is just saying, okay, if something comes in here, forward it there, attach the token, and so on. But YARP is super powerful. It supports, load balancing and round robin schemes and session affinity and many things, and has built-in support for Kubernetes and container orchestration and service discovery and you name it. Yeah. So instead of just using our simple wrapper around it, which is great for development time, you can also basically inverse the approach and just say, I'm using YARP directly and just take bits from the BFF framework, for example, the token management. Yeah. And that's something here. You can see basically that's kind of like the native YARP configuration system, right? So that's the thing that while sometimes people are a little bit confused with YARP, you have to learn a little bit of their terminology first before you can use this. That's why we decided to build a development wrapper around it to not make that investment upfront, I guess. Yeah. But basically YARP all has this thing called routes, right? And then you can say, okay, if something comes in on here, and then you have this catch-all thing, but this can be way more complicated, and you can match routes on headers and query string parameters and you name it, right? And then so basically what they say is like, whenever something comes in on that route, forward it to this cluster. Yeah. And so a cluster basically really is just a definition of a backend endpoint. In this case, it's the remote API, but you can have more than one destination, as I said, and you can have strategies of, dealing with that, like distribution of destination, as I said, round robins or sticky sessions and all kinds of stuff, basically. And it's also very extensible. So basically what we did is we said, okay, if you prefer to use YARP directly, you can just basically plug into our extensions into the native YARP config system, and then suddenly, by magic, or rather by an extension method, I guess, YARP will understand OAuth access tokens and will understand ND4 tree protection. Yeah. So, and that's then, and that ball comes back to the point where this gives you a lot of freedom to design a ready-made framework, because, in my experience, front-end developers are not security developers, right? They don't want to deal with this. They want to call APIs, and the whole OAuth thing and tokens is a distraction, and they were forced to learn this or to incorporate this somehow. And I think this approach just takes that burden away. Yeah.
Yeah, I think the awesome thing about this, like what you just said, is like front end developers can focus on the user experience rather than trying to do this juggling act between security and user experience. Like they know how to call an endpoint, they know how to get data back. That's good enough, right? And
that's how it should be, I think. Yeah.
Yeah. So, one last question, and then we can kind of wrap up. But some folks are asking, like, with the identity server licensing, like, are there any restrictions specifically around like governmental organizations in using or getting a license for identity server?
So show me that government organization which has less than $1 million budget.
Yeah,
I mean, there were no restrictions whatsoever, right? And we basically say, if you are an individual or if you are a company and you have less than 1 million budget, feel free to use it. If you are a non-profit, right, and you have less than 1 million budget, feel free to use it. Yeah. For government organizations, it's a bit tricky. Yeah, because I think it's very hard to I mean, even this, if you have less than 1 million budget, yes, of course, yeah, feel free to use it. Yeah. That is very seldomly the case.
Yeah. Just to let people know, I am starting my own country and I will be using the identity server license.
Right.
I'm just joking.
So, I mean, the thing we often say to government agencies is, if, I know they have budget planning, right? So if you have issues putting it in your current budget, we don't have an issue giving you it for 1 year for free, right? And then you can plan for the next budget.
Yeah. Yeah. Okay, great. Yeah, so I think this is a really good point. A lot of people stuck through the whole session, which, thank you everybody for who did. I think this was really fun. Again, Dominic is one of the premier security experts in the .NET community, so I want to thank him. I want to thank Duende Software for just giving us this opportunity to have this chat. And yeah, be sure to follow him on Twitter and ask him questions there. But other than that, let's wrap up. Dominic, do you have anything left to say? Do you want to say one last thing?
I think I said much more than we planned.
That's good. That's good.
It's I guess, when I made the decision like over 20 years ago that security is something interesting, I think it still is. So, we planned for roughly 60 minutes. Now it's almost 2 hours. And it was fun.
Thanks. Yeah. It was my pleasure. And let's end the show. And I'm gonna show my slides here. I'll add it to the stream here. So let's go here. So if folks want to know more about Rider or Duende Software, the links are on the screen right now. Check out our blog. That's where we write a lot of .NET content. Be sure to follow us on Twitter, JetBrains Rider. If you want to do me a favor, go to YouTube. If you're already on YouTube, like, subscribe, hit the notification bell to get more content. It actually helps us out to know whether we're doing a good job creating and booking content. I think this one is actually going to go in as one of the best ones we've done. So again, thank you, Dominic. If you want to check out Identity Server, be sure to go to duendesoftware.com and be sure to follow Dominic at Least Privilege on Twitter. He has a lot of cool stuff. I especially enjoy pictures of his truck, so go look at those. Those are really cool. And yeah, again, be sure to subscribe on YouTube. And thanks everybody for joining. And we'll catch you next time. Bye, everybody.
Bye-bye.